Hello guys. So today we study about the lens diagrams. So there are certain rules for drawing the lens diagram or any ray diagram that is concerned with lenses. So we'll be first going through the rules, and after that we'll go to the main part at which position the image and the object will be forming in case of concave lens and convex lens. So we've already learned that what is the first focus in case of concave lens and the convex lens both, and we also know that what is the second focus. We know the first focus is called principal focus, and this knowledge is necessary before this video that we are doing. If you are not through it, then please go through that and then again come back to this. So we have already in our offline class discussed about the first focus and the second focus in case of convex and concave mirror. For the first focus, we have said if it is the first focus, then you have to consider light ray coming from focus. Okay, if it is the first focus, you have to consider light ray coming from focus. Okay, if it is the second focus, you have to consider the emergent ray after refraction is either going to meet at focus or seems to come from focus. Okay, so these are the two things. So in case of concave lens, first will be the convex lens. Okay, the converging lens we have to do the converging lens. So this is the concave lens. Okay, so I will draw this. So let us go to the rule number 1. If any parallel ray parallel to the principal axis, this is the principal axis, any ray parallel to the principal axis is falling on a convex lens, then the emergent ray will hit the second focus. Okay, emergent ray will hit the second focus. In case of, if we see the same thing in case of concave lens, then we will see if any ray that is coming parallel, again the ray is parallel to the principal axis, the emergent ray will diverge out of the mirror lens, but it will seem to come from, if you have an eye over here, so it seems that the light is coming from focus. So this is again second focus. So if any parallel ray that is parallel to the principal axis hits a lens, incident on a lens, then either the ray will meet at focus, that is second focus, or the ray will seem to have come from the second focus if you put an eye on the emergent ray. Okay, now let us go to our rule number 2. Rule number 2 is, if you see, rule number 2 is if any ray is coming from focus, then it's just the opposite. If any ray is coming from focus, it will pass parallel to the principal axis. It is just the opposite that has happened right now in rule number 1. If you consider the concave lens, then if any ray seems to or directed at focus, if any ray seems to or directed at focus, then the emergent ray will be parallel to the principal axis. If you see the convex lens over here first, this one, so we can see that this is first focus. So I have said that first focus means you have to consider the incident light coming from it always. First focus means incident light is coming from it. So if you see over here the first focus, the incident light is coming from it. And if you see in the convex lens over here, concave lens, so convex lens is incident light is coming from first focus. In case of concave lens, you will see the incident light is directed toward the first focus. So the incident light is related with the first focus and the refracted light is related with the second focus. That's what we discussed in our offline classes while we explained about the focus, first focus and second focus. Okay, so here also if you see if it is directed towards the first focus, then the ray will pass parallel to the principal axis when it is emerging out of the lens. Third and most important is the light ray which is directed towards optical center will pass undeviated. It is undeviated. If you see, this is undeviated. Why this is undeviated? Because we are considering a very thin lens, already discussed in the last class. Undeviated in case of thin lens, very important. Okay, it is only undeviated because we are considering a thin lens. If we consider a thick lens, then it would not be undeviated. It will be deviated and there will be some lateral shift, okay, that we have discussed earlier in our offline class. Okay, so now one by one we will move to the lens diagrams and you have to understand what is it. Okay friends, so now we will be doing the convex lens. So one by one we will go through the ray diagrams right now. So first of all we will take the convex lens. Our first case is object is at infinity. So object is at very far place from the mirror. It is at infinity and the rays coming from it are parallel to the principal axis. So as we have seen right now previously that the rays parallel to the principal axis falling onto the convex lens or incident on a convex lens, the rays will refract and meet at second focus. Okay, the refracted rays are always related to second focus. Okay, so the rays will meet at second focus. So as we can see, whatever may be the size of the object at infinity, the image over here is very diminished. Okay, it is basically diminished to a point. Okay, image over here is diminished to a point. If you see, it is diminished to a point. Okay, so if we have to write what is the characteristics of the image, you can see the rays are actually meeting to form an image, so obviously it will be real image, and whether it will be inverted or erect, all real images are inverted, so we can write it inverted. Okay, number 3, so what will be the size of the image? As we have just now I have written that it will be diminished to a point, so we can write diminished to a point. Okay, number 4, where the image will be getting formed. Image will be getting formed at second focus or f2. Okay, so these are the 4 characteristics of the images that will be in this case. Where this type of lens is used, this case is used basically in case of burning glass. Okay, burning glass. So burning glass means basically you keep a lens over here. If you keep a piece of paper over here, then this paper will get burnt off, because all the sun rays that will be coming from almost an infinity distance is going to be concentrated. This lens will get converge and concentrate the heat of the sun rays towards this paper over here at focus. So in that case this will get burnt off by the heat, so that is why it is called burning glass. In this case is used for burning glass. Okay, so we'll now move to our next case. Our next part or the next case that we'll be going to consider over here, our next case number 2. So here the object is at infinity but rays are not parallel to the principal axis. As you can see, the rays over here is falling obliquely. Okay, but individual rays are parallel within themselves, but they are falling obliquely. So in this case, each and every ray will be converged to a certain point which will lie on the second focal plane, that is the plane of the focus. Okay, so it will lie in the second focal plane and this will be the image. So if we write the characteristics of image over here, again actually the rays are meeting. Please always draw these arrows, otherwise your ray diagram is not correct. So arrow is very important. Okay, so what is the characteristics of image over here? Image over here has to be real, so it will be inverted. Where will it be formed? It will be formed at f2 and it will be diminished to a point. So it will be diminished, which we can say highly diminished. Where it is used, it is basically used as a lens in astronomical telescope. Okay, please remember it is used as a lens in astronomical telescope. These uses are very important in case of lens and in case of the prisms. In case of prism, some prism is there which is used as a erecting prism. Please do all those prisms and those uses also. So ray diagram and uses both are very important. Okay, so we'll now move to our next one. Okay, so our next object is now the object is between infinity and the center of curvature. Okay? Our previous one was the object was at infinity, and now the object is between infinity and the center of curvature. Center of curvature is basically 2 into focal length. Okay, so it is written 2f. Okay? It is basically 2f, center of curvature. So now, if as you can see over here, one ray is passing through the optical center undeviated, and another is bending after hitting it parallel to the lens and passing through the second focus and forming an image which is between the second focus and the center of curvature. Okay, so here what is the characteristics of the image? If you see over here, number 1 should be real because the rays are actually meeting. What should be number 2? Number 2 should be, because you see here you can understand that real image is inverted, because if you see this rays which is coming from the top of this object is meeting at the and forming it at the downward position. So the top is becoming down and the down is becoming, if you take a ray over here like this which will pass through the optical center undeviated, optical center से जाएगा तो undeviated जाएगा, and it will form over here. So the bottom is getting formed at the top and the top is getting formed at the bottom. So here we can say it is inverted. Okay, number 3, size basically it is reduced. Okay, reduced size. Okay, we can write size is reduced. Okay, number 4, where is the object? We know where is the image is between f2 and 2f2. Okay, now where can this lens be used? This is generally used in photographic camera. Okay, photographic camera. Okay, now we'll proceed towards our next image and object combination. So this is our next object and image combination as we are going to discuss over here. So if you see over here, the object is at the center of curvature or 2 into focus. So this is basically 2f1. So one of the rays falling parallel will pass through the second focus, another will pass through the optical center, and another ray along the principal axis. Here also if you see the characteristics of the image, so number 1 it will be real, number 2 inverted, number 3, so if you see the size over here, then this size and this size is same, so there is no change in size when you have the object at center of curvature. Okay, size of image is equal to object size. Okay, object. And number 4, where is the image formed? Image is formed at 2f2. Okay, so where is this used? This is basically used as a lens in or terrestrial telescope. Okay, okay, so this is done. Now let us move toward the next object image combination. So this is our next object and image combination. As you can see over here, now the object has moved much closer to the lens and it is between the focus and 2 into focus, that is focus and curvature, f1 and 2f1. One of the ray falling parallel towards the convex mirror parallel to the principal axis, another is passing through the optical center. Do show all the arrows, otherwise there will be marks deducted or they may not give you any marks. So arrow is very important in ray diagram. Now this one of the ray which is passing parallel to the principal axis, that is the incident on your convex lens, is going to pass through the focus, second focus. Another ray is passing undeviated. As you can see over here, the image formed is beyond the 2f2 point. Image formed is beyond the 2f2. Okay, Here also you can say the image is real, and as you can, by the same logic that we have done in the previous diagram, it will be inverted. Image is formed beyond 2f2 and image size is magnified. Image size is magnified. Okay, image size is getting increased, so it is magnified. What is the use? It is used in cine projectors. Okay, रील से बहुत मैग्नीफाई होकर दिखता है अपने बड़ा स्क्रीन में. Nowadays this kind of projectors are not used, but previously it used to be. Okay, it used to be when reels were getting projected towards a screen made of basically a cloth, but the total reel, a small reel or a small film is projected, so film becomes much bigger in size. Okay, this is our next image and object combination. Here now the object is much more closer again, so it is basically at focus. So one of the rays passing parallel is converging at f2 and going on. Another ray passing through the optical center, it is also going on. So as you can see, these rays are parallel to each other and will never meet, and so the image will be highly enlarged. The image is formed on the opposite side, so it is real image. Image is inverted. The image is highly enlarged. ठीक है, image is highly enlarged. Okay, and it is formed somewhere at infinity. Okay, it is formed somewhere at infinity. Okay, so if you see our first diagram that we have done, so there the object was at infinity and image was getting formed at focus. Now the object is at focus and the image is getting formed at infinity, so it may form an image at infinity. Okay, so where this kind of lenses are used, this is used in searchlights. Okay, searchlights or spotlights, we use this. So this is our next one. So here the object is not at focus, focus and optical center. So object is between focus and optical center. So object has come much closer again. So here you can see the focus will be at this point. Okay, the principal axis. So one ray will pass parallel, another ray is going to go through the optical center. So if you see over here, the rays are never going to meet. These are getting diverged. So if I am having an eye over here, so I'll see that these rays are coming from here. So my image will be formed over here, but the head of the image is as per the head of the object. If you see, so number one characteristic will be virtual, number two it will be erect or upright okay, erect or upright. Number three, the image is obviously magnified. Okay, it is enlarged, so we can write that it is enlarged. Number four, where is it formed? It is getting formed, where it is formed, it is getting formed beyond 2f1. Okay, so that is clear to us now. So it is getting formed beyond 2f1. Okay, so what is the characteristic of this image? This image is very important. If the object lies between focus and the optical center, the image of convex lens will be virtual. The most important diagram. Where is it used? It is used in many places. It is used by palmists, for reading purpose. Okay, so this kind of things are used. Okay, very important, only case where the convex lens will be forming your virtual image, only case. Okay, normally the convex lens will be forming real image only if the object is between the focus and the optical center, it will be forming the virtual image. Okay guys, now we will be studying about the concave lens. So in concave lens, basically we have only two cases that we have to study. Remember, concave lens always produce virtual image. So there is no condition, there is no chance of any sort of real image in case of concave lens. So in concave lens there can be two cases. The first case when the object is at infinity. So this is the case where object is at infinity. So in this case the object is at infinity. So the rays will come parallel and it will diverge, and it will appear to be coming, the divergent rays that will appear to be coming from F2. So as you can see, the first thing is what kind of image it will be. It will not be real image, it will be virtual image. Okay, so and it will be upright. Virtual images are always upright. It will be diminished. Okay, and where it will be formed, it will be formed at F2. It will be formed at F2. Where it is used, this kind of lenses are used as an eye lens in telescope. Okay, it is used in telescope. So we have learned other telescopes also. So here it will be Galilean telescope. Okay, now characteristics of other images. So in this one if you see, this is the object is at any place other than the infinity, any place other than infinity. So between infinity and the optical center, it will be at any place other than that. So here the characteristics of the image will be basically virtual again, because you have to track back to get the image. So here this is the image, virtual, upright. So these are common, and obviously reduced in size, reduced in size. Sorry about the handwriting, I will change the pen. And anything else? Yes, anything else, that is where the object or the image is getting formed. It is always formed between F2 and optical center. Remember, this is always formed between F2 and optical center. And what is the use where it is used? It is used for correcting short-sightedness. Okay, so it is used for correcting short-sightedness. So these are basically all we have already covered up all the lenses, concave lens and convex lens. We have covered up the total lens part in only 25 minutes approximately. So this will help you to solve all the ray diagrams that is given to you. So please go through this video time and time again, draw by yourself, so that you can really have a grasp on this subject. Okay, so after this we'll come up with the sign conventions of the lens in the next video, and then we'll solve some problems on it. Okay, thank you.